Linux printing. In this nugget, we're going to look at printing in Linux. We're going to talk about some of the standard printing systems available in Linux, all the way back to the Berkeley Standard Distribution's line printer daemon, up to the current common Unix printing system known as CUPS. Now, printing has often been a source of frustration for system administrators, but hopefully after this nugget, you'll have the basics down so you can set up printing on your Linux system. Let's get to work. All right, well, let's start with a little overview of Linux printing. And I just want to give you a little bit of a history of Linux printing and show you sort of, how it's evolved to where it is today. And that'll help you make some sense of some of the options and some of the features that are in modern Linux printing systems if we understand sort of how it got there. So what you have to understand first is that PostScript is at the heart of Linux printing. PostScript is a page description language that was developed by Adobe. Okay. Now, PostScript is a computer language, and it describes a printed page with its language constructs, much in the same way that HTML describes, a printed page that you would see on an internet site. Okay. Now, modern Linux applications that include a print option produce PostScript data. All right. And so if a printer is PostScript ready, then basically the application can print directly to the printer and just print PostScript right to that printer. However, a lot of inexpensive printers don't understand PostScript. And so what you have to do is there has to be some sort of intermediary here so that, the PostScript that is being produced by the application then gets translated to something that the inexpensive printers can understand, and it can and will be printed then correctly onto that printer. Okay, so the idea here that intermediate step is what we call filters. And there's a few different kinds of filters that can exist in the printing process. One kind of filter is a conversion filter. So that converts PostScript to the native language of the printer. Conversion filters in combination with I/O filters transfer the data to the printing device. So these two kinds of filters here will take something that is not, will take PostScript and turn it into something that the printer understands and transfer it over to the printer as well. And then there's processing filters. So sometimes the document that you're going to print is in some format that is not understood by the printer. And maybe the document you're trying to print is not in PostScript format to start with. Then there's processing filters that will transform the document data into something else so that the printer can then eventually handle it. Okay, so that's the kinds of filtering steps that can go on in the printing process. Now, the basis of the printing system is the spooler. And what the spooler does is it manages queues of print jobs. And by a queue, we just mean, like an ordering, like a line in a bank or something. And each printer has its own queue, and the queue is processed in FIFO order, first in, first out. That's the definition of a queue. So the first jobs that come into the printer are the first ones finished. All right. Now, what we want to do here is we want to understand sort of the history of Linux printing. We have to start with the Berkeley Standard Distribution, the LPD printing system, the line printer daemon printing system. So this was developed for Unix back in the day, the Berkeley Standard Distribution of Unix. This printed to printers that could only handle one line at a time. That's why it's called a line printing daemon. All right. And that's a really, really archaic printing mechanism. Okay, nowadays we print graphics and tables and all sorts of fancy stuff on our printers. Back in the day we could print one line of text at a time to the printer, and that's when this was developed. Now that sounds really outdated, but that made it through to the very first Linux distributions, and it's still shipped with Debian and Slackware Linux, along with more modern printing systems. But the LPD printing system is still shipped with a couple distributions, and it was in the first Linux distribution that was distributed. All that the Berkeley Standard Distribution LPD printing system consists of is a daemon, a line printing daemon that's sitting there waiting for requests to come in. It's waiting. It consists of a couple config files in Etsy, and the main config file that it consists of is the printcap file. And we'll look at some example printcap files to show you what they're all about and what they do. It consists of a spooling directory, so like var spool lpd, and this is where jobs are kept in line for the daemons before they get processed. And the basic commands that it gives you, the LPD system, is an LPR command so that you can print a job, an LPRM command so that you can remove a job from the print queue, and LPQ so you can examine the print queue. So that's basically all the options that you have with the LPD system. It's very, very basic. So let's look at a print cap example. I've actually put a couple print cap examples here. The first one is just a really basic local printer definition, and the printer definition here is LP, and this is considered the default queue for the LPD system. So LP is your default printer, but the alias here, the vertical bar, and then the alias here is printer1. So you can specify LP or printer1 when you go to send a print job. All right, then there's some lines here, okay? SD is the spooling directory, LP is the device that it's coming from, IF is for any input filters, SH has to do with printing a banner page. So if a printer is shared amongst a lot of different computers, then some people like to print banner pages so that the first page that comes up will say Perry's print job, this file, this time, and so on. And that just makes it easy for people to separate all the jobs that are coming out on the printer and to find your particular job. The banner page is really easy to see. Okay, so that's one example of a printer definition. You can also specify things in here like size limits on files. You can put in a directive in here like :mx $0, and then that will allows for size limits on the particular files that come into that printer that you're specifying. The other thing that you can do with an LPD system is you can specify remote printers. Okay, here what you would do is you would give the spool directory, okay, again just like we did above. You would give the RM gives the remote server name, so you'd specify the fully qualified domain name of the server that you're using, and then you're also specifying a remote queue. All right, and that's the name of the queue that you would specify there. Then on the machine that is actually serving as the print server, there's a file on there called etc lpd.hosts, and in that file you specify the hosts that are allowed to forward jobs to your local daemon. All right, so that's the basics of the print cap files. The LPD system sends data in two phases. Okay, the first phase is it's the control files. So that's going to describe the job. So things like a username, a file name, options that you're sending to the printer, that sort of stuff. And then the second piece that the LPD system uses is the actual data in the file. Okay, so that's the basics of the LPD system. Then after LPD came along, then there was the LPR-NG system, NG just standing for next generation. So this, was basically an extension of the Berkeley Standard Distribution System. It uses the same format for the print cap file. So the print cap files that we just saw for the LPRNG system, it's basically the same. However, there is more advanced filtering allowed in the LPRNG system. There's also user-defined queues allowed, so in your home directory you can create a .printcap file, and that will specify, then you can specify settings for your particular jobs. And the other thing that the LPRNG system does is it allows System 5 print commands. So if someone was coming from not the BSD background, but the System 5 Unix background, then those commands will also work in the LPRNG system. So things like LP and LP stat, in addition to the commands that we saw just a minute ago, LPR, LPRM, and LPQ. Now all of that history has led us to the Common Unix Printing System, which is abbreviated CUPS. All right. So now for the next couple slides, I'm just going to barrage you with acronyms. Okay. So be aware. All right. So the common Unix printing system is based on the Internet Printing Protocol Standard (IPP), which is IPP is actually derived from HTTP, which we know is the Hypertext Transfer Protocol, and that's what we use on the internet. So every web page that you see is based on HTTP to transfer that traffic. Okay. Now IPP, because it's based on HTTP, makes deployment over a wide area network really easy. The other thing that IPP makes easy is that we can have secure printing. So just like HTTP can be secured with authentication and secure socket layers connections, IPP can be secured in the exact same way. So now CUPS, what it does is the CUPS daemon understands IPP requests. Okay, and it can use IPP to talk to its clients. However, CUPS also understands other protocols. And so CUPS can act as a bridge between some application that understands the IPP standard and something that doesn't, like some printer that doesn't understand the IPP standard. Okay, so the other thing is that CUPS understands or recognizes the PostScript Printer Definition Language, the PPD. Okay, and it extends the usage of the PPD to non-PostScript printers. So the PPD, the PostScript Printer Definition, is another Adobe standard, and this describes the capabilities of PostScript printers. But like I said, CUPS extends this to non-PostScript printers, so it's describing the capabilities of all these printers using this sort of a language, this PPD language. CUPS also allows a multitude of filters. Okay, it allows back-end filters, which means there's filters in place for parallel ports, TCP/IP sockets, line printer daemons, things like that. It also allows document conversion filters, so it can do things like convert images to PostScript. It can convert ASCII text files to PostScript, PDF files, TeX files, LaTeX files, which are word processor files for like scientific people that need to write like formulas and things. Okay, so all of those kinds of document conversion filters are in place for CUPS. There's also interface filters. So this will convert from PostScript to some intermediary format. And then there are translation filters, and so that's so you can print to non-PostScript printers. So, so all the kinds of filtering that we talked about a few minutes ago, CUPS recognizes or allows for all of those filters and sort of in an extended fashion so that it has lots of flexibility. Now, there's lots of advantages to CUPS. One of the advantages is printer classes. So basically what you can do is, instead of just having each printer have its own print queue, you can define this whole group of printers to be a class, and then that class of printers has one print queue for it. So then when you, as a user, want to print a job, you don't have to go out and look at all the different printers that you can print to and see, how many jobs are lined up in each one, and then pick a printer to print to. You can just submit your print job to this class of printers, and then there's sort of like automatic load balancing done. As soon as one printer finishes a job, then the queue is looked at, and the first job in the queue is taken out and put on the first available printer. So that takes, in a large setting with lots of printers, that takes a lot of the burden off the user to find a printer that's available. The user just prints to the class of printers, and then the system, the CUPS system, takes care of funneling out of that queue to the first available printer. There's also automatic network configuration for CUPS. So all the daemons that are on the same local area network communicate, and you can do things like browse queues and remove jobs and look for problems and things like that, all from one machine. So that makes administration of a CUPS printing system much easier than having to go out and constantly monitor all these different queues. CUPS also allows LPD and System 5 interfaces. So if you're used to either of these interfaces from before, you can still use those commands with all the various options to control your CUPS-based printers. And it also allows web-based administration. Okay, Other advantages of CUPS is that it easily handles non-PostScript documents, and we saw before that you can place filtering into the mix so that non-PostScript documents could have been handled by LPD or LPRNG as well, but CUPS just allows an easier handling of those documents. And CUPS also has a very intelligent filtering mechanism. So in a directory, etc CUPS, there you can create these conversion files, some file .convs. Those intelligent conversion files, what they'll do is each of these conversion files will say, information like what the input data to this conversion file is, what the output data to the conversion file is, as well as some other information. And then CUPS will go through and decide, say, take this document that you want to print. It will look at all these different filtering directives in this directory, and then it will decide and make the right choices for you to make all the conversions so that at the end, you've got what you need, either PostScript for a PostScript printer or some special language for your particular printer will be the end result no matter what the input was, as long as you've set up all the various conversion files that you might ever need. Another advantage of CUPS is that it's got a very simple C language API. Okay, and this allows easy integration into applications so that applications can print directly to a printer. So normally, like historically, I should say, for Linux and Unix, it was up to the user to do all of the conversions and things like that, and you couldn't just print right from an Emacs window, or you couldn't just print right from some programming language interface, or you couldn't just print from some word processing program. Okay, you had to save the file and then execute a command like print this document to the printer. All right. Whereas this C language API allows a printing interface to be easily integrated into applications. And actually, the GNOME and KDE desktops have both created tools to act as sort of the middleman, so that any application that works in GNOME or KDE can then just say print and use the GNOME print tools, and then GNOME will take care of the integration so that CUPS will handle anything from the GNOME desktop, or KDE has done the same thing with KDE print, so that will provide the mechanism to actually communicate with CUPS. All right, well, now let's move out to the Linux screen. I'm on my SUSE Linux machine here, and I want to set up the printer that I just plugged into the back of my computer, into the first parallel port. All right, so the way that I'm going to configure this printer is I'm going to go into the YAS2 tool. You have to be the root user to configure the printer for the machine, so I'll type that in. Under hardware, there is a printer option. And in that printer option, what's going to happen is, well, the very first time that you click printer, after you've plugged in the printer, it's going to go through this 1 or 2 minute detection mode. Okay, this happened really quickly right in front of you right now because I've already actually configured this printer once before I started recording the video, just to make sure everything was right. But the first time you do it, it'll take a minute or two to go through all the possible printer settings and things like that, and you can see that it's found my HP DeskJet 640C. It's on the first parallel port. Okay, if this is not correct, or if this was my old printer and now I've plugged in a new printer or something like that, I could go to restart detection so that it would reprobe to see what new printer is out there. Under configuration, you can set all sorts of things for the printer. This first page is just a description of the printer, the device location, things like that, the name of the printer. And then under the next thing, you can set all sorts of other stuff. Okay, here is the different configurations that you can set for your printer. So there's different configurations, like you can have normal as sort of the like a regular print job. We could do normal grayscale. We could do high quality or draft grayscale, and they would print slower or faster with different qualities based on which one you're choosing. If you're just writing some paper and you just want to proofread it on paper, you could just do a draft grayscale that will use less toner and print faster, that sort of thing. Okay, so under advanced settings, you can set all sorts of things. You can set the different page sizes you can use, whether you're printing to envelopes or legal paper and things like that. You can set all those things. You can set the modes like we were just talking about. You can set the orientation. You can set the number of pages per sheet, so you can do one or you can do two kind of side by side, or four and like, the four different corners of the paper. So in case you're just want to get a view of like what it is that you're printing, but maybe not be able to read everything at a very high font resolution or anything like that, then you can change those values. Okay, so I'm not going to mess with any of that stuff. And what we've done here is, the printer's been configured. Actually, under configure, you can actually the next page, you can do some test printing. Okay, so you can either test graphical or text printing. I've already done that, so I'm not going to click OK there. But you can test those to make sure they're all working okay. All right, so I'm just going to click aboard here because I've already configured the printer. I just wanted to show you how to use this tool. And now what I want to do is, from the command line, I want to show you how to use some of the tools to send print jobs to the printer, look for print jobs that are on there, and remove jobs from the queue. So I started by learning the BSD commands when I started doing Unix printing, and so I'm just used to those. And so the LPQ command is the command that shows you what jobs are in the queue for your printer, and you can see right now there's no entries in that job in that queue. And so that's one command that you should know for your Linux printing system. Another one is the LPR command to actually send jobs to a printer. So if I said something like this, -p normal, then that will choose the normal print queue for the printer, and then I can send it a job like .bashrc or something like that. Okay, so I hit that, and now if I do an LPQ, you'll see that it says my job is active, the owner's Perry, the job's 3. Maybe you can hear my printer going over in the corner there. This is the file name, and there's the size of the file, and now the job is being sent to the printer and it's printing. All right, now if you want to remove a job from the print queue, you can say LPRM followed by the job number, and now if I do an LPQ, it'll say no entries. One caveat here is that if the job is active already, you can do an LPRM and it'll kind of remove it from the queue, but it's still printing over on my printer. So a lot of that information already got there before I even was able to do the LPRM. If this was a multi-page print job, the bashrc file is only 1 page long, but if this was a multi-page print job, then it would probably cancel before all of the pages were printed. But it's the LPRM command can only remove stuff that the printer hasn't sort of taken control of already, where the LPRM command only affects the print queue on the print server, which is my Nugget SUSE machine. Okay, so that's what's going on there. But if I had, if there were like 10 or 15 jobs in this print queue, and I said LPRM to some job down in the print queue, like the 3rd or 4th or 5th job or even the 2nd job, then that job would actually be removed from the print queue and it would never show up on the printer. Okay, so there's the 3 basic commands that you need to know to do printing from the command line: LPQ, LPRM, and the LPR command is probably the most important to actually send jobs to the printer. All right, well, this might all seem really easy the way that I just set this up, but maybe you're saying to yourself, well, I'm not using SUSE Linux, I'm not using an HP DeskJet 640 printer, and so how is it all going to work for me? Or what do I do if something doesn't work? Well, you can consult a few different resources. One of them is the Printing How-To page. If you search for Printing How-To in the Google Linux search, then this page will come up. Another good printing resource is linuxprinting.org. I would show you that website, but it's actually down right now, so I won't show you that. But the Printing How-To website has a lot of good information on it. If you're actually buying a printer for your Linux system in particular, then it has all sorts of information on supported printers. So that's half the battle right there. If you have some old printer that's not supported, then getting it to work is going to be a big headache. Whereas if you get a printer like this HP DeskJet 640C, which is a reasonably cheap printer, and it's in the supported list, then everything's going to just work a lot easier. When the tools probe for the printer, they'll know what it is, they'll know how to set it up, that sort of stuff. Other things talked about on this website are spooling software. So we've already talked about CUPS. I told you about LPD and lprng. It gives you an overview of how CUPS and the Berkeley Standard Distribution line printer daemon works. It talks about configuring things. It also talks about vendor solutions. So like I said, I just showed you how to configure it for SUSE Linux. Maybe you're on a different distribution of Linux, and if something's not working on your distribution, you can consult this web page or this section of this web page to see if there's any peculiarities for your particular distribution and how to get things to work. This webpage also talks about the involvement of GhostScript, and it also talks about how to set it up for a network. So how to make your particular printer available all over your network, whether you're printing from Windows machines or from Apple machines and so on. Okay, so remember, this website, linuxprinting.org, is another good website to refer to if you need more detailed information about setting up printing on your particular system. All right, well, it's time to wrap up our nugget on Linux printing. We started by talking about the Berkeley Standard Distribution's line printer daemon. We talked about an important configuration file on the LPD system, namely the etc printcap file. And I showed you a couple examples of a printcap file. One was for local printing systems, and one was for remote printing systems. Then there was the LPR next generation system that came along that expanded and improved upon some of LPD's characteristics. But if you ask me, both of these systems have been supplanted in their functionality by CUPS, the common Unix printing system. Now, CUPS is gaining in popularity. The Apple's Mac OS X or OS X has adopted CUPS as its standard printing system, and other vendors are coming on board like HP and IBM to sort of define the next generation of printing infrastructure for Linux. Printing is one of the aspects of Linux that has sort of lagged behind the competitors like Windows. It's a lot easier to print a lot of different kinds of documents from a Windows system than it is from a Linux system, but CUPS and the Open Printing Project, which is coming along, have really shored up printing in Linux and made it a lot easier to use and administer printing systems in Linux. Well, I hope you found this nugget informative, and thanks for watching.